compass readings that don't always show the direction of true north, and interference with the operations of satellites are just a few of the problems caused by peculiarities within Earth's magnetic field. The planet's magnetic field radiates around the Earth and far into space, but it's all set up by processes happening deep within the planet's core, where temperatures exceed 5,000 degrees Celsius. New research, reported in the journal Nature Geoscience, suggests that the way the superhot core is cooled is key to understanding the causes of the peculiarities, or anomalies as scientists call them, of the Earth's magnetic field. In the extremely hot temperatures found deep inside the Earth, the planet's core is a mass of swirling molten iron which acts as a jet dynamo. As the molten iron revolves, it generates Earth's global magnetic field. Convective currents keep the dynamo churning and turning as heat flows out from the core and into the mantle, a layer of rock that extends some 2,900 kilometres up to the planet's crust. Scientists have found that this cooling process isn't happening in a uniform way across the planet, and these variations are causing anomalies in Earth's magnetic field. Seismic analyses have identified regions of the Earth's mantle, primarily under Africa and the Pacific, that are especially hot. And computer simulations have now revealed that these hot zones are affecting the cooling of the planet, reducing the cooling effect on the core, and this causes regional or localized changes in the properties of the planet's magnetic field. For example, where the mantle tends to be hotter under Africa, the magnetic field at the top of the core is also likely to be far weaker. And this results in a weaker magnetic field projected out into space above the South Atlantic Ocean. And that, which scientists call the South Atlantic Anomaly, causes massive problems for orbiting satellites. The study's lead author, Jonathan Mound from the University of Leeds, says one of the things that the magnetic field in space does is deflect the charged particles which are constantly streaming out from the Sun. But where the magnetic field is weaker, that protective shield isn't as effective. So when satellites pass over this South Atlantic Anomaly area, these charged particles can interfere and disrupt with their operations. In fact, NASA needs to shut down the Hubble Space Telescope whenever it's orbiting over the South Atlantic Anomaly. And crew aboard the International Space Station also experience computer glitches when they're orbiting over the anomaly. Scientists have known about the anomaly over the South Atlantic ever since they began monitoring and observing the magnetic field. But what's not known is whether this is a long-term feature or something that's just happened more recently in the history of the planet. As the lead studies revealed, these anomalies are likely to be caused by differences in the rate at which heat is flowing from the Earth's core into the mantle. The whereabouts in the Earth's inner structure these heat flow differences happen is likely to dictate how long they could last. Mound says the processes in the mantle happen very slowly, so we can expect to see temperature anomalies in the lower mantle which have stayed the same for tens of millions of years. Therefore, we can expect to see properties in the magnetic field they create have also been similar over tens of millions of years. But the hotter outer core is likely to be a dynamic fluid region. So the heat flows and the magnetic field properties they cause would probably fluctuate on shorter timescales, perhaps as short as just a few hundreds or thousands of years. This is SpaceTime.